Mark your own. Here we go. And Sirki. Skydiver is in free fall. Mitchell, I jumped out of an airplane. She has been falling long enough to hit terminal velocity. Which of the following statements are true if she's hit terminal velocity? A, there are no forces acting on the skydiver because she's not accelerating. True or false? What are the forces acting on her? Get the obvious one. What else? I guess this would be where air resistance would come in. So I totally agree. False. The magnitude of the gravitational force is less than the magnitude of the force of air resistance. True or false?
False.
Why does it have to be false? If it was less than, would the forces be balanced? So that would mean that she would be, I'm looking for where it starts with letter A. So she would be accelerating. Okay? The net force on the skydiver is equal to 0. That's true. You know how I know? She's not accelerating. By the way, which one of Newton's laws have the last 3 all been examples of? If you haven't noticed the punchline, it's been the same law every time that I keep coming back at you for. Okay? Newton's first. Yeah. Once the skydiver pulls her parachute and starts to slow down, the net force on the skydiver is pointing up. She's moving down, but she's slowing down. Which way is she accelerating then? Up. Which way must the unbalanced force be? Up. I agree. True. Half mark for each of those. 2 marks in total. Find the acceleration of both masses if there is no friction. This is a job for a free body diagram. I'm going to have M1G, normal force number 1, tension, M2G, normal force number 2, F applied, tension. If there's no friction, looking at the tug of war along the rope, I'm pretty sure that F applied is winning. We're accelerating to the right. So it's going to be F applied minus tension plus tension equals M all times A. Oh, I love it when I lose tension. I've earned it. It looks like A is going to be F applied divided by M all. It's going to be 42 divided by 10 plus 15. Is there a clever way to divide by 25 in my head? I could times by 100 and then divide by 100 and times by 4. That'll work. 16.8, 1.68? 1.68. Meters per second squared. 2 out of 2 if you got that. Otherwise, I would give you a half mark if I saw that, a half mark if I saw that, half mark for the numbers, and a half mark for the answer. Find the tension between both masses. I would use mass 1 because it's cleaner. I would go tension minus no loser equals M1A, also because it's the 10 times table. M1 is 10. A is 1.68, so 16.8 newtons. That would get you 2 out of 2. Did anybody use mass 2? I can tell you how to do it. So you would have F applied minus tension equals M2A. Then on your next line, you would have F applied minus M2A equals tension, or tension equals M2A F applied minus M2A. And so you would go 42 minus 15 times 1.68, but you still got 16.8. Yes? Mine's a little shorter. But again, full credit. Okay? I would give you, in this case, 1 mark for that, half mark for the numbers, half mark for the answer. But as always, if you got it right, 2 out of 2. Following system is moving to the right and slowing down. Find the acceleration. Alrighty. Still going to have M1G, normal force. But I guess here, I'm going to have friction force number 1. And then tension this way. On the second mass, Madison, I guess I'm going to have M2G, normal force number 2, F applied, and then I'm going to have not only tension, but I'm also going to have friction force number 2. If I'm slowing down, which way am I accelerating? To the left. So who's winning? Same answer. Yeah, so my equation is going to look like this. Friction 1 minus tension plus tension plus friction 2. I'm so used to friction being a loser, but in this case it's a winner. Minus F applied, that equals M all A. Okay, again, I can stretch and lose tension, and I guess to get the A by itself, I'll divide by M all. I'm going to end up with A equals, don't forget to divide by M all. There was somebody, I forgot to do that. It's going to be mu times normal force number 1. Wait a minute, I don't know normal force number 1. Oh, but look. I don't know the force the same size as normal force number 1. M1G minus mu M2G. Well, it's mu times normal force number 2. I don't know normal force number 2. Oh, but look. If I plug in the numbers, it's going to be 0.24 times 10 times 9.8. And I didn't write everything. First of all, Mr. Dewick, this should be a plus sign. I am so used to making friction a negative, and I forgot to drop the 42 down. That was terribly sloppy, Mr. Dewick. Got to be better than that. It's going to be plus. People on YouTube were screaming at me. Sorry, YouTubers. Times 15 times 9.8 minus 42 all over 10 plus 15. I have no idea what the answer is here. This one I won't try and do in my head. 0.24 times 10 times 9.8 plus 0.24 times 15 times 9.8 minus 42. Close off the top, divided by bracket 10 plus 15. Close off the bottom. Did you all get 0.672? Barely accelerating. Barely slowing down. Almost in equilibrium. A equals 0.672 meters per second squared. If you got that, 3 out of 3. Otherwise, I would probably give you 1 mark for the main equation. I'd probably give you a half mark for that, a half mark for that, and then 1 mark for the answer or something like that. Find the tension between the two masses. I think I'd use mass 1. Lily, did you use mass 2? Wow. Okay. We'll get the same answer, but you'll have done way more work. Because mass 1, I think I can go friction 1 minus tension equals M1A. Got to do a swappy dance. And I'll get friction 1 minus M1A equals tension. I'm going to put the T equals over on this side. So it's going to be mu M1G minus M1A. Tension is going to be, what's mu? I don't know what's mu with you. 0.24 times 10 times 9.8 minus 10 times 0.672. 0.24 times 10 times 9.8 minus 10 times 0.672. And I get, what did I do wonky here? Did I make a typo? Yeah. 0.98. Sheesh. By the way, how did I know I was wrong? I got a negative T. I set this up right, I'm pretty sure. So I figured it had to be a calculator typo. 9.8. That'll work better. 16.8? By a total fluke, you get the same tension as part B that from the previous question. That's completely a massive fluke. I didn't plan that or anything. In other words, I don't want you to spot a pattern that isn't there. Oh, the answer's always 16.8. No, that was a complete fluke. Lily, did you get the same thing with mass 2, but with way more writing? 2 out of 2 if you got that. Otherwise, I would probably give you a half mark for that. I'd probably give you a half mark if I saw that, half mark for the numbers, and a half mark for the answer. Ooh, elevator questions. So what I'm going to try and do is a generic free body diagram. And then Madison, because we're in grade 12, I'm going to see if I can imagine the arrows getting longer or shorter as I need them. Because Madison, I know in the elevator question, the tug of war is between gravity and the normal force. That's the tug of war, because that's what a scale measures. So in A, we're accelerating up. So which force would be winning? Yeah, my equation in A is going to be normal force minus mg equals ma. I'll come back to that. In B, we're accelerating down. Lily, which force would be winning? And so you can, as you're getting good at this, if you see that you have a bunch of the same type of question, you can sometimes get away, Zaina, with doing a generic free body diagram and just imagining the arrows getting longer or shorter. And I won't freak out if you do that. Now, I got to be honest. On a test, I would probably do a free body diagram for each question. And even on a quiz, I'm feeling a little, maybe I should have done one for each question. In your homework, though, if you feel you can kind of see how everything's fitting together and use the same free body diagram over and over for part A, B, C, and D, fine with that. Okay. Looks like they want me to find the scale reading. Well, the scale reading is the normal force. So in part A, it's going to be mg plus, oh, you know what? It's going to be, mg plus ma. It's going to be 75 times 9.8 plus 75 times 1.6. 75 times 9.8 plus 75 times 1.6. And do you all get 855? Does this person feel heavier or lighter? How many kilograms does this person feel like their mass is? How would I convert this to kilograms, Sarah? Yeah, so just for giggles, if I wanted to, instead of having a mass of 75 kilograms, they feel like their mass is 87.2. 1.6 meters per second squared. If you've ever been in a high rise that has an express elevator, or where I've seen them more often is in Las Vegas hotels where they're trying to get people in and out. They want to get you out of the room as fast as possible, and the more time you're on the casino floor, the more money they're making. So they're investing in elevators that move you up or down really fast. So there I felt an acceleration, I'll bet you, of about 1.5, 1.6, and you can feel it. But then you really quickly hit a constant speed. Once you're at a constant speed, what's your acceleration exactly as a number? So then you feel your normal. So it's just for a brief instant. Here, I would do the swappy dance. You're going to get mg minus ma equals the normal force. It's going to be 75 times 9.8 minus 75 times 1.25. I'm kind of lazy. I noticed that I could bring back this line here and just change the plus sign to a minus sign and the 1.6 to a 1.25. Did y'all get 641 and change? For both of these, if you got it right, 2 out of 2. Otherwise, it would be half mark for the original equation, half mark for getting the normal force by itself, half mark for the numbers, and a half mark for the answer. Same with B. Oh, what did we say if you're moving at a constant velocity, Keegan? What's your acceleration exactly as a number? 0, which means it's a tie. In other words, in my free body diagram, the normal force just equals mg. So it's just going to be 75 times 9.8. I should be able to do that in my head. It's going to be 750 take away 19.6, I think, Mr. Duix. 1.9. Oh boy, I'm slumping. I'm going to have to do this on my calculator. I should have had that. 735. Duix. And Nick, what if the elevator is accelerating downwards in free fall? What would the scale read exactly as a number? Yeah. No, that'd be First of all, I'm going to have to pick on you. You said the scale would read an acceleration. Duh, it's a bad guess, right? What would your normal force be if you're in free fall? Yes. Remember the OK Go video I showed you last year where they had rented the airplane and had it do parabolic dives so they could get moments of weightlessness? Gravity was still there, but the normal force was gone. So 2 marks for that. Can you give yourself a lovely score at the front out of 19, please? And if you need to lawyer with me, now is the time.